This is the third part of our fourth lecture on Gauss law. We've introduced all about Gauss law and relevant things about it. We're going now to do applications, examples on the different types of symmetries and how to find the electric field using Gauss law. Some of the applications are problems included in the references that we stated at the beginning of the course, mainly from the second reference اللي هو دندش and مرزوب. Okay, the full solution will be provided to you أكيد during when I upload the classroom, the coming classroom. Okay, now our example we're going to start with is something that we know the answer in advance by Coulomb's law. Okay, فإذا هذا لحتى to check whether our work is correct, but we're going to do that using what? Gauss law. Our example هو find using Gauss law the electric field due to a point charge. كلنا بنعرف الانسر حيكون KQ على distance square, بس I'm going to use Gauss law. Okay, so what I have دايما بالGauss law بدي ارسم. So I have a point charge Q and I'm looking for the electric field created by it using Gauss law. So the way of solving here as such, we're going to say this is a spherical symmetry problem, implies a spherical Gaussian surface of center at Q and radius, any radius R is selected, over which Gauss law is applied. Okay, so صبايا وشباب بس I selected the spherical Gaussian surface, I have to draw it on the figure. So هذا البوينت تشارج هاخد أنا sphere of radius R يلي أنا اخترته. هذا الجاوشن surface لاحظوا I'm drawing it dotted لأنه not existing in reality. هذا something imaginary يعني منه موجود. أنا I'm constructing it to find the electric field using Gauss law. Okay, هذا الجاوشن surface of radius R center Q. Okay, I'm going to apply and it's closed, it's a sphere, it's a three-dimensional. Okay, I'm going to apply Gauss law on it. Okay, what does it say Gauss law? It says phi E هي integral ل d phi E بس عم نحكي over هيدا الجاوشن surface. It's integral, closed integral of vector E dot vector dA, okay, equal to Q enclosed على epsilon naught. هيدا هو actually الجاوشن surface. I'm stating it and I'm going to use it to find what? Electric field created by هيدا point charge Q. Okay, how do I find it? I'm going to handle هيدا law and see left part of the equation, what does it end up with, and this it ends up with what. يعني بدي احط محل كل شيء شو عندي. مثلا Q enclosed شو هي, what does it, what is it? Okay, so the way of solving هي as such. I would say closed integral ل E dot dA هي actually closed integral للmagnitude of E, magnitude of dA, cosine الانجل بيناتهم between E and dA as vectors. طيب هيدا الكوساين الانجل بدي اعرف الانجل بدي اجيبه من الفيجر. اوكي, so on my figure okay شو عم نقول بدي شوف الفيكتور دي اي والفيكتور اي شو هن على الفيجر. الدي اي it's element area selected on this whole area. So in other words على my figure هاخد جزء من هو سفير كله سفير. اوكي هاخد جزء وسميه دي اي. هيدا it's of area دي اي. بس انا ما بهتم للاريا دي اي. اوكي بعرف انه اريا دي اي بس it's characterized by vector دي اي. on my figure where is my vector دي اي؟ شو هو؟ it's a normal vector to the surface area. هيدا surface area part of a sphere. the normal to the sphere هو radial line و radial line can be هيدا radial line. اوكي هيدا radial line. here it is. this is the radial line. طيب radial line وبدي ارسم هذا الفيكتور. is it this way ولا inward outward ولا on inward ولا inward؟ دايما the vector normal بياخدوا اذا عم بحكي vector perpendicular to a surface where the surface هو part of something closed دايما بياخد outward normal. outward يعني الفيكتور area هون it's this way. هيدي هي الفيكتور area دي A. It's of magnitude dA equal to this with direction normal as you can see here. Okay. Now بدي electric field at this dA. طيب ما أنا هيدا من السيمتري هيدا spherical symmetry problem. فإذا electric field wherever على selected Gaussian surface is radial. هلا radial inward ولا outward depending على sign of the charge. هيدا positive فإذا دايما هون radially outward. لو Q is negative بيكون radially inward. فإذا على هالدي A particularly here it is. This is the vector E which is if you compare it مع DA مع DA you can notice that it is what parallel. So E DA cosine 0 degrees and the reason for this since E parallel to DA both radially outward as seen in the figure. Both radially outward. Now طيب next step okay cosine 0 يلي هي شو 1 so it is closed integral لل E dA. okay طيب إسا فيني يكفي أنا الشغل بهيدا left part of the law. اوكي طيب أنا اخترت spherical Gaussian surface لأني عارفة all of its points are of constant magnitude of E. هيدا uniformity هيدا symmetry. اوكي طيب being constant فيني طلعه برات الانتجرال. so here it is E outside the integral. And the reason for this, since E is constant over selected Gaussian surface. اوكي صبايا يا شباب. طيب شو بقي عندي؟ E ضرب الانتجرال لدي A. انتجرال لدي A is area. فإذا E ضرب الاريا. بس أنا ما معي الاريا بدي جيبها. area of what? of the selected Gaussian surface. كلنا بنعرف الاريا of sphere what is it? okay so it is E ضرب الاريا of the sphere which is 4 pi r square. okay هيدا اللي وصلت له من الليفت side of the equation. بقي عندي الرايت سايد. اوكي طيب this is all equal to what? equal to حكفي بالورقة اللي بعدها. اوكي this is so لوين وصلت ل E ضرب 4 pi r square اللي هي what? الاريا of selected Gaussian surface. okay surface equal to equal to Q enclosed على epsilon naught. شو عم نقول؟ equal to what's inside it in terms of sphere in terms of charges. طيب على الفكر هيدا السفير شو في بقلبه charges؟ في بس الكيو اللي على السنتر. اوكي واللي شو قيمته؟ it's a cube. so here it is, this is it. اوكي so equal to الكيو يلي على السنتر اوكي على epsilon naught يلي هو شو؟ it's a plus q على epsilon naught. باخد هيدا الجزء وهيدا الجزء اللي اخر شيء وصلنا لهم. اوكي equating them together we get what? E equal q على 4 باي epsilon naught r square. اوكي يلي هو actually what؟ هو it's k q على r square يلي هو بنعرفه by coulombs law. اوكي right. فإذا هيدا I've managed to find the electric field at any point okay at distance r. طيب هلا احسبوا انه مثلا particularly okay suppose that okay suppose okay numerical application they're saying E equal what at r equal أو at distance equal to let's say 2 centimeters from Q. okay what do you do؟ ما انتو هيدا so الانسر انا بعرف at any r اللي E equal Q على 4 باي epsilon naught r square so implies at r equal 2 centimeters. بس ما بدنا أنا بدنا نحطها as a unit يعني 0.02 meters. okay implies ال E equal to Q على 4 باي epsilon naught 0.02 okay كلها squared okay بيكون معي الفئين etc. right. هيدا بيكون خلصنا أول example يلي سهل وقدرنا قررناه بالشي اللي بنعرفه فطلعت معنا النتيجة. I will stop now وبرجع بعطي فيديو تاني. okay